Hello everyone and welcome back to our Python Data Science Workshop series. I'm Chi and I hope you're enjoying the tutorial so far. In today's video, we will be learning structured data in Python. This is also the last episode on the basic programming part of this series. In the next one, we'll start learning about data processing and analysis and how to use tools such as NumPy and Pandas. But today's session will help to set the foundation to understand them. So first, what is structured data? To understand it, we can think of something familiar, for example, an Excel spreadsheet. So imagine an Excel spreadsheet with its rows and columns. Each row is an entry, and each column represents a specific piece of information about that entry. For example, if we had a spreadsheet of weather data, then each row might represent a different day of the weather observation. And then the columns could be things like temperature, humidity, precipitation. And this example is just to give you an idea of how a structured data set will look like. So typically, it is organized in a consistent format that is easy for human and also software to access. The structure approach is incredibly useful, especially for environment data collected over time. Now, what's cool about Python is that it gives us really useful tool to work with this type of structured data. We call these tools collections. Within collections, we have some special types called sequences, where the order of the items matters. In previous sessions, we have already learned two common sequence types, that is string and also list. And today we're going to explore three more data structure in Python. They are dictionaries, sets, and tuple. And so now let's begin. So the first collection that we're looking at today is dictionary. So dictionaries are a fundamental part of Python collection types. They allow us to organize data using a key value framework, which is very useful when we are structuring complex information. Dictionary is mutable and unordered, which means that it can be modified, but the elements within the structure cannot be referenced by their position and they cannot be sorted, which means that there is no indexing in the dictionary objects. Now let's take a closer look as an example. So how can we create a dictionary? To create a dictionary, you can use the curly brackets and provide both a key and a value, which are separated by a column. So if we look at this example here, we're trying to create a dictionary of different environmental disciplines. So we have ecology, hydrology, geology, and meteorology. This is what I was just referring to as the key and value. So the key is the first part before the column. In this case, is ecology, and its value in this case is the description for this display. And if we execute this code, we can see that we have now a dictionary objects that are printed. And the way to access a certain element in a dictionary is pretty straightforward if you know the key. For example, if we want to know the definition of ecology, then we could just use the square brackets and put ecology to access the value. And this is going to print the definition of ecology. So now I want you to pause the video and try to access other disciplines in our dictionary. You can try hydrology or geology. And because dictionaries are mutable, so it is also very easy to add new entries to a dictionary. For example, we can add geomorphology to the environmental discipline dictionary, and this is done using the following notion. So you can just specify a new key, in this case, geomorphology, and then directly you can put the value, which is the evolution and configuration of landforms. And if you do this, you can see that our environmental disciplines has been updated and the geomorphology was appended to this dictionary. So now again, another exercise is that you can try to add biogeochemistry also in our dictionary. So now if you want to access the key and values in the dictionary, Python provides some built-in methods to access them. So if you want to access the keys, you can just put dot keys and parentheses. This is going to print all the keys in the dictionary. Same for the values. So what the keys and values function does is that it will return a dictionary key and also a dictionary value object, respectively. And each of these objects contain a list of the keys and values. And if you want to have them as a list object, you can use the list command to wrap them. And this is going to return you in a list object. As here, you can see that this is actually a dictionary key, but if we put a list function, you can see that now the outer part is a square bracket, and this is telling us this is a list object. So we can also, similar to a list, we can also loop through a dictionary. And Python provides a very efficient way to loop through all the keys and values simultaneously. And this is done using the items method. So the item method will return a tuple containing a key value for each element in a dictionary. So let's look at a practical example. Use a dictionary containing information about a famous cartoon character, which is Homer Simpson. And now let's say we want to print out all the information in a formatted way. Here's how we can do that using a for loop and the items method. So the myDictionary.item will return the key value pairs, and then as similarly to what we have done using the enumerate function previously in our for loop, because the item function will return two elements in one pair, that is key and value. So here we're using this for loop to unpack the tuples into key and value, and we're using again a formatted string to print them. So if you execute this code, you're gonna see that the name, occupation, so all the basic info of this cartoon character has been printed. So again, you can also try to similarly to what I've just presented, to loop through the environmental dictionary and print out a sentence providing the definition of each subject. A common challenge when we are working with dictionary is accessing elements that might not exist. And to know how to handle this is crucial for writing robust code that doesn't crash when encountering unexpected data. So let's keep using our environmental data set as an example. Say, I want to retrieve the definition of a field that hasn't been defined. In this case, I want to access the information about external hydrology, and let's see what will happen. We're gonna see that Python is giving us an error, and this is because these elements is not included in our dictionary. So to avoid this error, Python dictionary have a very useful method called get function, and let's see how this works. So as you can see, if I'm trying to use the get function to get information about external hydrology, we can see that the output is none because this key does not exist in the dictionary. And this is much safer than directly trying to access the key because that will give us an error if that key does not exist. And also, the get function will allow you to pass an additional argument. This additional argument specifies a default value which will be returned if you get an undefined element. So again, if I just run the updated one, we can see that now we have a notification saying that this discipline is not defined in our dictionary. Now, I would also encourage you to use the list of discipline that we have and to write a for loop that either prints the definition of the discipline or print discipline not defined. Moving on, now let's look at another important data collection type in Python, sets. First of all, what are sets? So sets in Python are unordered collection of unique elements. They're very useful for comparing group of items and determine their overlap or differences. While they are sometimes used in data science, they're less common when working with large data sets. Some of the key characteristics about sets are first, it is unordered. So unlike list or tuples, which we will learn later, sets Similarly to dictionary, they doesn't maintain a specific order of the elements. Secondly, sets are mutable, so which means that you can add or remove elements after creating a set. And the third is that it has unique elements. So sets will automatically remove duplicates. It does not allow any duplicates in a set. And the first one is that it's also iteratable and we can loop through the elements of a set. And similarly to dictionary, we also use the curly brackets to define a set. And in this example, I'm creating two set variables. First is a number set, and second is a string set. And you can print them. And another way to create a set is using a set function. You can also put a number list, and then you can use the set function to convert the list into a set objects. And as you can see, the square bracket of a list has been converted to curly bracket. Now you can try to use the set function to create a set containing the first four prime numbers. So, as we introduced early, one of the key features about sets is its mutability, meaning that we can change their contents after creation. If you want to remove an element from a set, you can use the discard function. In this case, we'll discard the ecology elements from the string set. And you can see that ecology has, which is the first elements when we define it, has indeed been removed by using the discard function. Second, you can also add a function using the add. And here we're trying to add oceanography into our string set. And if you want to add multiple elements to a set at one time, you can use the update function. The input for this should be a list. And in this case, we're adding two new elements into our string list. And as you can see here, we're adding oceanography again. As I introduced before, that set can only contain unique elements. So we only still got one record of oceanography in our set. Now you can try to also add biogeochemistry and meteorology to our string set. And also, many of the same function that worked on list will also work for a set. For example, you can also use the length function to access the length of a set, and you can use the minimum and maximum function to retrieve the min and maximum value. And for string, this corresponds to the alphabetic order. And here is the result. And here is another exercise. You can try to use the length, min, and max commands to find the length, minimum, and maximum for our number sets. And now another thing to notice is that it is usually a good idea to make sure that your sets only contain the same basic data type. The reason, as we said before for list, similarly, is that Python doesn't know how to compare the magnitude of different data types. If we have a mixed set which contain numerical value and also string character, you can see that this will bring an error because in this case, the order comparison is not supported between the instance of integer and string. And now, moving on, let's talk about some set methods. And because of their similarity to mathematical sets, there are some specific functions that allow us to compare and combine the content between different sets. So the first relationship I want to introduce is union. So a union of sets contains all the items that are in any of the sets. So basically, you're trying to merge the sets together to a single union. And these graphs, as showing here, you're trying to combine the sets of A and B into a single union. And in this example, you can see that we are creating two number sets. One contain odd number and the other contain even number. And if we use the union function, this will merge them to have the full integer from 1 to 16. This is returning us the merged sets. The second relationship or the second method you can do is intersection. So an intersection of set contains odd items. that are found in all of the sets. It's the part where they're overlapping. So for example, here I'm defining a set of squares and also a set of multiplies of 9. And what the intersection function will do is that it's going to trying to find the elements that are both in squares and multiplies of 9. If you run this code, it will identify 9 and 16, which are both squares and multiplies of 9. Now you can try to use the intersection method to do this little access. So here we have sets of people who know Python and a set of people who know R. And now I want you to use this intersection function to find people who know both Python and R. Okay, so if you finish the exercise now, let's move to difference. And a difference of two sets contains all the items that are in A but not in B. So again, continuing our example of squares and multiplies of 9. And if you use the difference function in this case, what it will do is it will try to find all the elements in the squares that are not multiplies of 9. This will give us the result of 16, 49, 4, and 25. And you may realize that the output in this case is not in order, and this is because sets by itself is an unordered collection. And now here is another exercise. You can try to use the difference method to determine, in the previous example, who knows R but not know Python. Finally, here is what we call symmetric difference. So this method will return all the items that are unique to each set. It's also called disjunctive union. So what does it mean is that basically it's taking out the intersected part out of the sets and only retain what is unique to each of the set. In this case, again, if we're using our square and multiplies of 9, the symmetric difference will return us the value that does not contain the elements that are both squares and multiplies of 9. And now I would suggest you to use the symmetric difference to determine who only knows either R or Python. Moving on, there are also some other additional set method. The first one is disjoint, and this will determine if the two sets are disjoint. It will return true if the contents of two sets are completely distinct, and false if they have any overlap. So here we're using our example of odds and even that we identified, that we defined before. If you don't remember them here, so we have the odd number from 1 to 15 and even number from 2 to 16. And we know that they are disjoint, and this will return us the true value. And the second is subset, and this will return a true if the content of set A is a subset of set B, and false if it's not. Here we are defining a new number list which is primes, and in this case it contains the odd number from 1 to 11, and we're trying to assess if prime is a subset of odd, and in this case it's indeed. The third one is superset, and this will return true if the content of set A is a superset of set B. And if we run this again, this will also give us true because we know that odd list contains all the elements in the prime sets. Now, finally, let's talk about tuples. And as we have already mentioned a lot of time before, tuples are a type of sequence in Python. It's similar to list, which we have already seen. However, there is one key difference between tuple and list. That is, tuples are immutable. This means that once a tuple is created, its contents cannot be changed. And a tuple is implemented using a parenthesis. Here, in this example, we're defining a tuple object constituted of numbers. And it can also be strings. And similarly to a list, a tuple can also contain mixed data type. but this is usually not recommended. And because they are both sequences, tuples and lists share many same method. For example, you can again using the length, min, and max function to access some basic information about your tuple object. And here is a little exercise for you to run. And also there are other ways to create tuples. For example, instead of using a pair of parentheses, you can also using a trailing comma for a tuple within a single element. And also you can create tuples with multiple elements by using commas to separate the items. And finally, you can use the tuple function to create a tuple. And noted that an iterable is any object that is capable of returning its contents once at a time. And as we discussed before, strings are also an iterable object. So the tuple function will unpack, in this case, is unpacking the earth string into individual character. So it's returning us EARTH, the 5 letters in this tuple. And now here is an exercise. You can try to create 3 separate tuples that contain the geolocation of the following cities, and then try to create a new tuple that is a tuple made of the 3 city location tuples. And as you learn with list, any elements of a sequence data can be referenced by its position within a sequence. So the indexing for a list will also be applicable for a tuple. In this case, recall our number tuple defined before. Here we're trying to access the first element 4. And -2 will return us the second last element on the tuple, and that is -12. And also, again, you can use the tuple function to create a word tuple of this very long English word. And here we're trying to access the 15th element, and that's an S in this case. And also, you can specify the steps when you are doing the indexing. And this will return us the character in a step of 3 from the start to the end. And now here is another exercise. You can try to use index to create a new tuple from the second element in the string tuple and find the third elements of this new tuple. A key important characteristic about tuple is its immutability. In Python, all objects are either mutable or immutable. Mutable objects can be changed after they have been created, while for immutable objects, they have a fixed value that cannot be altered. Tuples, along with numbers and strings, are immutable. This means that once you create a tuple, you cannot change its contents. So for example, if here I'm trying to overwrite the first elements in my tuple with 3, Python will give us an error telling us that tuple object does not support item assignment. And because of this immutability, tuples do not have the same robust set of functions that a list has. If you are trying to change a tuple, for example, if you're trying to append an element, this will also raise an attribute error. So here, if we create a tuple of colors and we're using the append function to append pink, again, Python will return us an error saying that tuple object has no attribute append. So a workaround is that instead of appending data directly to the existing tuple, if you indeed want to change the contents of a tuple, you need to create a new one or modifying the variable by redefining it. So here in the example, we have again the tuple list of different colors. And here I'm overriding the tuple of colors object by adding a new pink element, and this will give us the updated tuple of color object. So just to clarify, here we're not modifying the original tuple. Instead, we are creating a new tuple that combines the old one with a new element, and then assigning the new tuple to the same variable name. And you may wonder why this immutability matters. This is because it gives us several advantages to maintain data integrity. So once created, a tuple's data cannot be accidentally modified, and because of this characteristic, tuples can be used as dictionary keys or set elements. And also, in some cases, tuples can be more efficient than lists. One example will be that, say, if you are developing a climate change model and there are several key parameters that should be consistent, unchangeable throughout the whole analysis. And for this, we will want to use the tuple object to store the key parameter instead of a list to ensure that our model is precise and using the same parameter throughout the whole modeling process. And this is all we have for the first part of our Python data science workshop. I hope you have enjoyed it so far, and please try to do the exercise by yourself, and we look forward to see you in our next tutorial.